did you find out the meaning of the word mean?
Yes, miss.
And I hope nobody in here is mean. But you need to be liberal, giving, freely share. Now, the concept of mean in mathematics, which is from a branch of statistics, also has two other little partners that it walks around with. And if you can recall, we talked about the mode as the median, or the median and the mode. So we talked about the mean and the mean and the mean. Well, let's give the mode and the median some attention also. Ready for us to plunge?
Yes, miss.
Yes. Good, that's the attitude. So here we're looking at the median and the mode. So what is the main objective this afternoon? Is to find out how we can find or determine the median of a set of information or the mode of a set of information. What else do we need to take note of? The mean, the mode, and the median are all called measures of central tendency. As I was saying with the mean, it is one value that helps us to understand all the others that are there. And the median and the mode does the same thing. That one central value. And that value takes the place of many others. Further, the mean, the mode, and the median are also referred to as statistical averages. So we can use that and make an estimate, a rough idea as to what is going on. Now let us try to find out how is it we locate or we find the median. But before we get on to that, the median, listen to the sound of the word, median. What other word comes to mind when you hear median? Middle. Something about the middle. What about the middle?
The median of a set of numbers, for example, 4, 10, 3, 15, 8, is the middle value of the set when the numbers are arranged in ascending or descending order.
Thank you very much. Now let's take note of key phrases. Is the middle value of the set when the numbers are arranged in ascending or descending order. So let's skip the middle value for a little while and let's go to ascending or descending. When we ascend, we start where and end where?
Start from the bottom
To the top.
We start at the bottom and we go to the top. Now Daryl is a little more specific. He said we start from the lowest and we go to the highest. Descend now.
highest.
So we're top of the stairs and we get down to the bottom. Good. So we take these numbers that we're given and we arrange them in either of the two order. And then we look for the middle value. The middle value in that arrangement. So let's see how 10, 4, 3, 15, and 8 were arranged. But before we arrange them, one of the things we must take into consideration is if we have an odd set or we have an even set. Now let's hear what this little illustration says. Yes, Darrell, read that for me.
If the set has an even number or item, there is no single middle number. The median is taken as the mean of the two items in the middle.
Lovely, lovely. If the set has an even number of items, there is no single middle number. The median is taken as the mean of the two items in the middle. Now let us check to see whether we have an odd or an even situation here. How many do we have here?
5.
1, 2, 3, 4, 5. So here we have the numbers 4, 10, 3, 15, and 8. So we are not in the even situation where there is no middle. We know that there is a middle there. So let's continue. Now before we look at an example, let us arrange those numbers in ascending or descending order. The choice is yours. Which one?
Ascending.
Ascending. So we're going up. So which is the first one I should write? 3, 4, 8,
10,
10,
15.
15. So there we have them. We're going up. 3 is the smallest and 15 would be the largest. Which one falls in the middle?
8.
So 8 becomes the
Median.
for that set of data. Alright, let's look at another example. So here we go with a set of numbers or runs scored in an innings. But in this case, we have a bowler taking a number of wickets. In the first inning, he took no wicket. In the final inning, took 2 wickets. And then we can see across the first inning, he took no wicket. And then in the final inning, he took 2 wickets. And then we can see across here a number of wickets taken. So, what is the intention there? Find the median. You arrange in ascending or descending order and identify the median. But one thing you must take cognizance of is what? Whether we have
Odd or even number.
excellent, Daryl, whether we have an odd or even situation. In this one here, will it be odd or even?
Odd.
It's odd. How do you know right away it's odd?
Because it's 9.
Excellent, Alicia. It's 9 innings. So identify the median for me quickly. Come on, Stephon. Put them in order and identify the median for me. Do you agree with him?
Yes,
Yes,
miss.
Certain? So we have a 0, 1, 2, 3 ones, a 2, a 3, a 4, a 5, and a 6. And then we're 9. So the fifth one should be the median or in the middle. Very good. Give Stephon a round of applause there for me. Very good. Very good. So let's keep on finding out about the median. So there it says, first we have to arrange them in order as Stephon did. Then the middle value is 2. So there we go, 4 on our left and 4 on our right, and that leaves our 2 in the center. So since 2 is in the center or the middle, we can say it's like a pivot, and it balances the 2 on the other sides. Okay? So that 2 is identified as the median. Let's continue finding out about the median. A group of students were asked their ages in years. These were the answers that were given. That's a lot of ages. Why do you think they give you that information? With the aim of finding the what?
Median.
The median value or the median age. Find the median age. So what's the first thing you're supposed to do?
Arrange in ascending or descending order.
First thing, you arrange them in ascending or descending order. What other condition you need to take into consideration?
If they're even or odd.
If the amount of data given or numbers given would be even or odd. In this case, is it even or odd?
Even.
It is even. So let's quickly arrange them in order before we see the solution. So what's the first?
11,
11,
12,
12,
12,
12,
13.
13,
13.
another 13,
14.
14,
15.
15,
And 16.
and 16. How many of them are there?
13.
8.
8, sorry.
8 of them are there. 8 of them are there. Good. So, if we take 3 on our left and 3 on our right, our middle two are two 13s. Now, in a situation like this where we have an even number, we have 8 of them. We use these two that are in the middle. But how do we use them? What do we do with them to find that middle?
Add them and divide by 2.
And remember, there was a previous concept we learned about where we sum and we divided by the amount. What was that concept called? The mean. So you see how we're using the mean in the median? The solution of the median? Good. So, you're suggesting to me that we take the two of them, we sum them and we divide by 2. 13 twos are
26.
26. And what is half of 26?
13.
13. So we are saying here that our median is 13. Let's see if that is so. So we write the 8 is in ascending order. So there we have the middle. But on both sides of the middle, we have our 13 and our 13. So here we have the sum of the two, and then we find half of the amount, and we end up with our 13. So our median there is 13. So this is for the even situation. When there is an odd situation, we don't have need for that. We arrange in order and we find that center, that pivot. Okay? So now let's see what else is there to say either the mean or the median are averages that we should always have on our fingertips in our daily lives. Example 3. We have a set of scores there again and we need to find the median. How many scores are there? 6. Now in the previous example, what we noticed is that we had a 13 and a 13 in the middle. Now some persons might want to say, oh, the same value must be in the middle. But it's not always that way. Now let us quickly arrange this set in ascending or descending order. Let's go. 2, 3, 4, 5, 6, 10. How many of them are there? 6 of them. So let's say 2 on our left and 2 on our right. So the middle 2 would be 4 and 5. So the mean of the middle 2 would be 4 plus the 5, and then we divide by 2, and it's 9 divided by 2, and that would give us 4 and a half, or 4.5. Let's see if we're on target. Now let's see if we're on target. So here we have our middle point, and the median is 4.5. So we nailed it. Very good. So there we have our median, and we must always remember that if you don't arrange them in ascending or descending order, then your answer will not be correct because we're looking for that center of all the data that we're given, that one piece in the middle. And then you also have to take notice, take cognizance of if the values are all, the amount of them that are given is odd or it's even. So there's one example where we had the median odd, go to the middle after arranging them in order, and we found that because of even amount, quickly and easily and effortlessly, we found the median. Then we had a situation where we got an odd set of numbers, but then in the middle we had two numbers that were the same. We had a 13 and a 13. Now, it's not always like that. Like in our previous example, we had maybe a 5 and and a 3, you know, or you can have, we had 4.5, which is a 4, and a 5, which gives us a 9, and we had a half of 9, which is a 4.5. Okay?
Yes, miss.
Good. So here we have another set of numbers, and we want to identify the median. Now this is a question that was taken from the 2006 National Grade 9 examination. So if we're given the numbers 6, 3, 5, 1, 0, 8, and 4, and after we would have done our ascending or descending ordering and identifying our odd and even situation, what would have been our median?
4.
C.
4 at C. So those who would have selected C as their answer, 4. Now let's see if you got that correct. Yes, you got it correct. Very good. Very good. So there we looked at the median. We say the median is that middle value. When it's an odd amount of numbers, it's very simple to identify. Always remember, arrange them in order. Smallest to largest or largest to smallest. And then look for that center value. However, if we have an even amount, then we have to be a little more careful because we have two center values. We find the mean of those center values, and that becomes the median of that set of numbers. So we looked at the mean, we looked at the median. So which is the next one we're going to explore?
Mode.
The mode. And sometimes I like to look at the mode as the most popular one around. And when I say the most popular, means it finds itself popping up a lot. So let's see what it's all about. There's a little difference when using the mean as compared to the mode. There's a little difference when we compare the use of the median and the mean. The median gives us a better overall value, a better overall impression of what is going on in the set of numbers that we have. Now let me demonstrate what I was saying to you. For example, we're looking at the mean, and we have 2, 3, 5, 9, 10, and we have 53. Let's add 1 in front here too. How many numbers we have there?
7.
7. Now let's quickly calculate the mean for this set of numbers. So we sum them and divide by 7. So let's go 53 and then 63 and then 73. Take 1 would be 72. 72 and 8, 80, and 3 would give us 83. So we have 83 and we divide by 7, and that would give us
11
and 11 and 6 upon 7. Okay? Let's look at the numbers. We have 1, 2, 3, 5, 9, 10, and 53. So we have one that is far away from the numbers, the major set. So that one tends to change what, or gives us a different reflection than if we have all of them bunching around the same area. Now let us look at the median here. So we have our 1, 2, 3, 5, 9, 10, and again we use our 53. Which one is our central value?
5.
5 is our central value. 5 gives us a better picture as to what is going on either side. So the mean is affected by those far outlying values like 53, or in this case, maybe we had negative 17. The mean is affected. On the other hand, the median is not so much affected by them because the median always stays fixed to the middle. It is only that middle value or the middle values that affect the median. The mean, every one of them affects it. Everyone here had to be summed in order for us to get the 83. But it's only whatever is in the middle here affects the median. So there are times when the median is used to give a better overall impression of the typical values of the numbers because it ignores outliers. So 53 doesn't really matter there if we had a number on this side. This central one is what we're looking for here. Any questions there?
No, miss.
No, miss.
Good. So we explored the mean, we explored the median, we looked at how sensitive the mean and the median can be. Now let us see what the mode says. Good. So the explanation I gave you is further enhanced by what we have here. So read for me quickly.
The mean is a more precise measure than the median, but can be greatly affected by a few numbers that are very different from the other members of a set.
Good. So here we have it demonstrated. There we have the numbers 1, 3, 5, 9, 11, and 131. So you notice this huge difference between this set here and the 131. So you see this 131 has actually influenced the outcome. But this 80 is not a very good reflection of what is going on there. So we said the mean is sensitive to these outliers. However, when we look at the median, 1, 2, 3, 4, 5, 6. So if we take 2 and we take 2, our center 2 would be 5 and 9. 9 and 5 would be 14. The divider by 2 and that gives us 7. 7 gives us a better picture or a better representation or a better overall representation of the larger amount of values. Okay?
Yes, miss.
Good. So now we move into the mode. Yes, Evander, tell me about the mode there.
The mode is the value or group in a set of values that appears with the greatest frequency.
With the greatest frequency, it appears with the greatest frequency. It's like we have a colleague in school, and every time you look out, the colleague is there, and you look out, the colleague is there, and you look out, the colleague is there. I tend to say that's the one that's the most fast, the most inquisitive. Okay? Now, let us find out something else about the mode. Read for me.
This value or group is easier to find if the information is displayed in a frequency table or arranged in order of size. If the values are all different, there is no mode. Example, 2, 4, 6, 8, 10.
So how is it simple? Again, like the median, we arrange them in order of size. And then we look for the one that is most, that we have written the most. Now, before we look for the one that was written the most, there are situations where we have a group, but all of them are there once, or maybe all of them are there twice. None of them pops out or appears more frequently than the other. For example, we have a 2, a 4, a 6, a 8, and a 10. In this case, there is no mode. No mode. All of them are on the same plane. Now let us check to see what happens if we have one or more popping out. And then we also want to find out if we can have just one mode or several modes. Sometimes 2 or more values may present themselves as modes. So here we have a set of numbers arranged in order of size. 1, we begin and we end at 8. And then we have a 1, 2 2s, 2 3s, 5, 6, 7, and 8. So we have the 2 and the 3 occurring the same number of times, or appearing the same number of times. So we say both the 2 and the 3 are the modes. So this set of information is referred to as
The
what?
mode.
Yes, it is the mode, but there are 2 modes. When it's one mode, we say it's unimodal. It's unimodal. When it's 2 modes, we say they are
Multimodal.
multimodal. We want a prefix for 2.
Guy.
No.
Double.
No.
Twice.
We want a prefix, or uni means 1. What is for 2?
By.
Bi is for 2. So this here is called a bimodal distribution. And if there are 3 modes, what would it be? Trimodal distribution. Very good. Trimodal distribution. Okay? Now let us see what the next example. Now let us go to the next example. Both 2 and 3 are modes, and the example is said to be bimodal. Means it has 2 modes. Trimodal means it has 3 modes. Now sometimes we need to think that yes, we want to learn about the mean, the mode, and the median. But how do we apply them? How do we make use of them? Why do we need to learn about the mode? The mode is useful in businesses. For example, we have a shoe business or we have a clothing business. We look to see maybe what size is selling, is the most popular size that is being sold. For example, maybe we went into Colors Boutique or maybe went to Beaners and we inquire from the manager which is the size that goes the fastest, that customers come in and pick up the most. And they might say size 8 for women and size maybe 10 for men or 9 for men. So if that size is being sold the fastest, it means that it has implication for the manufacturers. If that size is sold the fastest and the most, that means that the manufacturers will have to make more of those. So for women, maybe they might make 100 size 8. Maybe they might make 10 size 7. And they might make 15 size 10. So where they're going the fastest, that is where you supply the most. So you see how supply and demand comes in with the mode?
Yes.
And how it helps businessmen and manufacturers to produce and order. So let us see what else is there. So here we have the same example. Or we can talk about clothing. Or yes. For example, tops. Maybe size 12 or 14 might be the going size. Anybody want to suggest how the mode can also be used apart from clothing and shoe sizes?
Stationary equipment.
Stationary equipment. Can we be a little more specific?
The books, the pencils, the amount of pens being sold are.
The books and the pencils. Or maybe if we're looking at the books, we can look at which type of book is the most popular book being bought. Exercise books, because there are some of them, as soon as you put the pen tip there, the page goes into 2 pieces. Okay, so you might look for the stronger one. Which one that the company is producing goes faster. Or maybe there's a particular type of pen. Or maybe printing paper. Okay? As Delicia says, she likes Pilot. But then there are different quality of Pilot. Which one is going faster? That is the one the businessman is going to order in larger quantities. So here again we have the shoe sizes. And here we have the manufacturer making more of the one that is more popular. Further, what do you think about hats? The general population, we have an average size head, or do we have a distribution of head sizes of heads? I think generally we have an average size. Okay? Why is Gabrielle laughing? We have an average size, and then with cups and hats, there are times when there are implements there to adjust the size. So generally you really don't have problems with hats. So let's look at example 5. The table shows the total marks scored by each student in a class. What is the mode? So here we have our frequency table. I want somebody to help me interpret what is being revealed there. Yes, Yannick, you
On
want
the
to?
frequency, 1 is the mode.
1 is the mode.
Because it shows up 4 times. 4 times.
Are you sure?
1 and 2, sorry.
1 and 2.
1, 2, and 3.
Well, before you go there, Yannick, I would want us to interpret what the table is telling us before we come to the decision as to which one is the mode. What is the table saying? Let us remember when we had that frequency table with the mean.
Yes.
We had 100 oranges were picked up by 10 farmers. So somebody help to explain. I want somebody to explain here for me.
At first, 3 students got 11, then followed by 1 with 12,
3 students
got 11,
obtained 11 marks.
1 with 12,
1 student obtained 12 marks.
4
Yeah.
with 13,
And so
Yeah.
and so on. 2
And
with
so
14.
on. So in this column we have the marks, and in this column we have the number of students who obtained these marks here. So let us say it was a mock test. The lowest mark was 11 and the highest mark was 12.
20.
20, sorry. So in going through the papers, the teacher would have observed that
Most students got 16 marks.
excellent. A higher number of students obtained 16. And that 6 students obtained 16. So with that said, can we identify the mode for that distribution?
Yes.
What is the mode?
6.
16.
16 is the mode. And 6, it is the 6 that tells us or helps us to identify that mode. Because, as we were saying when we were looking at the mean, this 11 is like this. 1, 2, 3. So, the 16, we would have seen it 6 times written out there. Okay? 16 popping out. And it's always popping 6 times. So 16 was the most popular number in this distribution. Hence, it is called the mode. And because there is only one mode here, we say this distribution is what type of distribution?
Unimodal.
Unimodal. One mode. Unimodal. 16. And that's a good mode for such a distribution. That shows we have some very good students who are mathematically inclined in that class. So let's look at the solution. Here we have our frequency table again. And the most frequent score is 16. Then the score, because the most frequent score is 16, the mode is 16. So let's continue. Let's look at example 6. Want to read for me, Delicia?
The mode of the set of numbers 1, 4, 4, 5, 5, 5, and 7 is
What do you think is it, class?
5.
It's 5. Why is it 5?
Because
5 is the most popular.
It occurs 3 times. as compared to 7, which is 1, 4, which is 2, and 1, which is 1. Very good. So the mode is 5. So let us make sure that we are correct. So this question here was actually taken from a past National Grade 9 examination paper. And as you said, the mode is 7. So those who would have... The mode is 5. You're all awake. So the mode is 5. So those who would have selected C as their answer, they definitely would have gotten it correct. See here, our key is C. And again, it's from the National Grade 9 examination in the year 2006. Very good. So that was example 6. Our National Grade 9 examination reflects the concepts that are being taught in the syllabus, and also it reflects whatever was being planned in that book that was set by our local mathematics experts. Okay? Now, we were looking, we delved into statistics, and we came up with 3 concepts: the mean, the mode, the median. Now, we emphasize today on the median and the mode. And we said the median is that central figure which characterizes or tells you or reflects or portrays something or a central value about a group. Now, in order for us to get there, to find or identify that median, we first have to take that set of information and arrange them in order. So either we go ascending order or we go descending order. That's the first thing you must do. It's critical that you do that. So after arranging them in ascending or descending order, you look for one other thing. What is that other thing?
Even or odd.
Excellent, Dara. We look for the even or the odd situation. Okay? When it's even, we're going to take those central 2 values and find the mean. When it's odd, we arrange them and we just find that pivot, that central value there. And then we have our median. And we say also that when we compare our mean to our median, the median is not that sensitive to far away values, the values that are not very close to the main bunch. Also, as we went on, we looked also as that mode. The mode, which is that value, as I say, is very inquisitive. It comes up, or it appears, or it shows itself up most frequently. If all the numbers appear the same number of times, it indicates that
There
is no mode. And if 2 of them are in a race, it becomes bimodal. But if there's one with no contender, it will be unimodal. So we agree that a distribution can have no mode, one mode, go Evander, 2 modes, which would be
Binomial.
and
3 modes.
and
Trimodal.
good. And we can have 4 modes too. 5, 6, 7, 8, 9. Depending on the quantity of data we acquire. Okay?
Yes, miss.
So we looked at the mean, we looked at the mode, and we looked at the median. And I hope none of you take on the disposition of the mean, the other meaning of the mean. Okay?
Yes.
You be like the median and the mode, which helps businessmen and manufacturers to run an efficient business. Now that was about the mean, the mode, and the median. And remember, we always give you exercises to work. And then we also look back at what was supposed to be done. So let us also continue by looking at some problems that are going to be worked that will help you with the mode and the median. Now for today's lesson, you're going to go to page 106, on where you'll find exercise 9B, questions 2 and 4. This information is coming from, or these questions are being taken from our normal book, Mathematics for Secondary Schools in Guyana, book 3. And we continue on page 107, exercise 9C, questions 2 and 6. Now let us examine the last set of homework that you had. You had to work question 10. Read question 10 for me.
3 children have an average age of 7 years, 11 months. If the youngest child is not included, the average age increased to 8 years, 11 months. Find the age of the youngest child.
Find the age of the youngest child. So let's do some analyzing before you give me your answer. When we have 3 children, 7 years, 11 months is the average age. The youngest child has been excluded. So, if we take 1 from 3, we're left with 2. So then we have 2 children, and the average age is increased to 8 years, 11 months. So we have 2 situations. 3 children, 11 years, 7 years, 11 months. 2 children, 8 years, 11 months. What's the age of that child that we took out?
Young.
6.
6 years, 11 months.
Evander said the child is young.
Is the age?
6 years, 11 months.
Like 6.
Yannick says 6 years, 11 months. You're sure, Yannick? Remember, the 7 years, 11 months represents 3 children. What is the actual age or years that represents the 3? Remember, that only characterizes that one figure shows the 3. What is the actual years for the 3?
About
7 years, 11 months is the average for the 3. That 1, it represents the 3. But that doesn't tell us how many years the 3 of them add up to. Good? So what I want you to first think about is, what is the equivalent in years for these 3 children? This is just the mean. That's just the average. That's just that one figure that tells me something about the 3. But altogether, how many years are between the 3? And altogether, what is the age of these 2? The average is 8 years, 11 months. But then that's not the figure for all the years of those 2.
23 years, 9 months.
For which, Evander?
The total for the 3 children.
For the 3, Evander came up with 23 years, 9 months. How did you get that, Evander?
I multiplied the ages, the average age of the 3 children by 3.
Multiply by 3. So 3 by 7 would give us 21. So that would be years. And then 3 by 11 would give us 33. And that's months. But then in 33 months, how many years do we have? We have 2 years. And how many months?
9.
And 9 months. Okay? So the 2 and the 21 would give us 23. And the remainder 9 months we bring back. So between the 3 children, the actual age is 23 years, 9 months. Remember, it is this we divided by 3 to get to the 7 years, 11 months. So if this is for the 3, what about the 2? You see why I said he's going to be Dr. Evander? Come on, tell me about the 2 now.
16 years, 20 months.
16 years, 22 months. 22 months. But then, 22 months would be more than a year. 22 months would be 1 year. Yeah.
10 months.
1 year and
10
10 months. So 16 and 1 would give us
17 years.
17 years
And 22
10
months.
months.
10
10
months.
and 10 months. Good. So the 2 worked out to be 17 years and 10 months, and the 3, 23 years and 9 months. Now, if we know the 2 and we know the 3, can we not find the age of that young child?
Yes,
The youngest one? How do we find that?
You subtract the total ages for the 2 children from the 3 children.
So we're going to take out 17 years, 10 months from 23 years, 9 months. So we have 9 months and we have 10 months. So we cannot take there. So what are we going to do? Take a year from here. And we're going to take across 12 months. 12 and 9 would give us
22.
21 months. So if we take 10 out of 21, we're left with
11.
11 months. If we take 17 out of 22, we're left with
5.
5. So that young child would be 5 years, 11 months. Yes, Yannick.
When I check the answer, I think you can add the 3 children for 7 years, 11 months, and the 2 children for 8 years and 11 months. You can get 5 years, and you put back the 11 months, cause the this is most. There's the
11
both of them get 11 months inside.
Take 2.
Add the 3 children with the 2 children, that's 5 years.
Oh, no. No, Yannick, I wouldn't want to encourage you to go down that road, because if we add 2 to 3, we're adding children against months. Big difference. Human beings and months. No. Units aren't the same, so we cannot go there. No. It's good to think out of the box, but no way. I cannot encourage you to go down that line. No way. Good to see that you're looking at things the other way, but it's just a coincidence that two children and 3 children gave us 5, but this is 5 years, so we cannot go down that line. Now let us see if we are on the right route. Let us see if Dr. Dalrymple has given us the correct guidance. So there we have the product of the 7 years, 11 months on the 3, and we have 23 years, 9 months. The age of the 2, 17 years, 10 months. And to find the age of that young child, which is 5 years, 11 months, we found the difference between the age of the 2 and the age of the 3. And yes, you're correct. 5 years, 11 months.
3 to go.
So here we have the total age of the 3 children. First, they took the product of the average and the number, and we got 23 years, 9 months. Then they looked at the 2 children, 8 years, 11 months by 2, and we got 17 years, 10 months. And then they found the difference between the two as you observe here. And yes, we're correct, because the age of that little child, as Evander said, the child was young, 5 years, 11 months. Very good. So here we're demonstrating again that yes, the exercises that are given in the book do challenge us to think and really think logically, and to think and to reason. And that is one of the the strong areas of mathematics. And those are things that make mathematics beautiful. And if you have the reasoning and your logic is developed, then everything else in life is fixed. Once you can reason and you have logic, you have that comprehension and you can interpret, which mathematics basically is responsible for, then life is beautiful.